Greetings, Max McLeod, aka the Nutrition Ninja Doc here, to quickly review the 4Ms and take a deeper dive into understanding the mitochondria and how to improve their function. I've spent over 50 years intensely studying health, nutrition, fitness, and natural therapies. I've learned a lot and still feel like I've just scratched the surface. I constantly strive to put it all together to improve my efficiency at helping people to achieve their health goals. Developing the 4Ms concept is my latest breakthrough. If you haven't watched the first presentation on the 4Ms that introduces the overall concept, I urge you to do so as soon as possible, as it will help you to understand how it all fits together. The basic idea is that health and our bodies are extremely complicated. There are far too many variables for anyone to stay aware of and manage. We need a simplified model to help us. That's the whole point of the 4Ms concept. It helps to make sense of the key factors that influence and control our health as well as our ability to heal. Here's a quick diagram showing the 4Ms: microcirculation, mitochondria, metabolism, and muscle. The microcirculation was covered in the initial 4Ms explanation as well as a deeper dive presentation. In this presentation, we're going to focus on the mitochondria. Mitochondria are subcellular organelles that are basically bacteria that formed a symbiotic relationship with single-celled organisms many millions, if not billions, of years ago. Their DNA is different than the DNA in the nucleus of our cells. That DNA is inherited completely from our mothers, so mitochondria are clearly something special. Many nutrients, including oxygen, must make their way to the mitochondria for them to do their thing. The mitochondria are primarily known as the powerhouses of our cells in the body. They produce or package about 95% of the ATP the body makes every day. It's estimated that our mitochondria make about our body weight in ATP daily. ATP is the primary energy currency of the body and therefore of our metabolism. It's used to drive all of our bodily processes that allow for life itself. Mitochondria are the epitome of use it or lose it. When we become inactive, our mitochondria lose volume, become much less efficient, and literally die off. When we increase our activity, they grow and replicate, thereby increasing our energy producing capacity. Think about this carefully. The mitochondria are the only structures that use oxygen. That should tell you how special and important they are. Way back in the 1920s and 30s, Dr. Otto Warburg received 2 Nobel Prizes for his work on the mitochondria. He demonstrated that there's only one primary cause of cancer: damage to the respiratory cycle of the mitochondria. All other factors are secondary or contributing causes. In other words, cancer is caused by mitochondrial dysfunction. Over the past 20 or so years, scientists have learned and confirmed that all chronic disease is due to mitochondrial dysfunction. So they are that important. Mitochondrial dysfunction can impact virtually any and all cells, tissues, and organs of the body: the brain, eyes, heart, blood, muscles, liver, kidneys, pancreas, hearing, colon, and the DNA, both nuclear and mitochondrial DNA. Here's a partial list of diseases caused or aggravated by mitochondrial dysfunction. Think about this one: premature aging, and perhaps all aging itself. ALS, Alzheimer's disease, autism, cardiovascular disease, chronic fatigue syndrome, dementia, diabetes, Huntington's disease, migraine headaches, and Parkinson's disease, just to name a handful. ATP cannot be stored, so it must constantly be produced. During intense exercise, the body can produce up to 1 kilogram per minute. At rest, it produces about our body weight in ATP every day. Mitochondria can take up to 25% of the total cell's volume. An average cell uses about 10 billion ATP units per day. The brain uses approximately 70% of the total ATP produced. The mitochondria are especially susceptible to damage from nutrient deficiencies, toxins, medications, antibiotics, and oxidative damage. They are the primary site of free radical production since they are where oxygen is metabolized. These free radicals can leak from the mitochondria and cause significant damage to other cellular structures as well. Mitochondrial leakage is the primary source of free radical damage in the body. Here are some of the factors associated with increased mitochondrial damage. Oxidants, as just mentioned, leaked as ATP is produced. These produce reactive oxygen species. Aging is associated with accumulated oxidative damage to the mitochondria. Genome susceptibility or damage, especially ApoE4. Toxic metals, persistent organic pollutants, such as BMAA, many prescription drugs, and alcohol. Want some confirmation that oxidative damage from the leakage of free radicals from the mitochondria is a major contributor to aging and disease? It's well known that the better a species is at protecting its mitochondria, the longer that species lives. The better a species is at protecting its mitochondria, the longer that species lives. Partial list of drugs that damage mitochondria: acetaminophen, antibiotics, aspirin, AZT, adriamycin, cocaine, crisafolpin, indomethacin, L-DOPA, methamphetamines, nucleoside reverse transcriptase inhibitors, NSAIDs, and statins. How badly do antibiotics, as an example, damage the mitochondria? After 4 days on ciprofloxacin, ATP production is down 90% and reactive oxygen species is up 250%. 4 days on ampicillin, 75% reduction in ATP production and a 200% increase in reactive oxygen species. Kanamycin, another antibiotic, after 4 days, 80% reduction in ATP, and a 240% increase in reactive oxygen species. Tetracycline, milder than the others, a 20% reduction in ATP production and a 40% increase in reactive oxygen species. The other two indicators, there are other toxic byproducts that come as a result of damage to the mitochondria. Many environmental pollutants harm us by damaging our mitochondria. Polycyclic aromatic hydrocarbons are an example. Another is beta-methylaminoalanine from algae blooms. Cationic metals such as lead, cadmium, mercury, and manganese have also been shown to accumulate in mitochondria preferentially, causing damage. Amophilic xenobiotics, ethidium bromide, paraquat, 1-methyl-4-phenylpyridinium, and mycotoxins are some examples of toxins that damage the mitochondria. Strategies to improve mitochondrial function: open, restore, and reset the microcirculation with EWOT, exercise with oxygen therapy. It's the only thing documented to do that. So if we can open up that microcirculation, it has a huge impact on mitochondrial function and efficiency. Next, optimize nutrient status to limit leakage of oxygen and high-energy electrons from the electron transport chain. This is the greatest source of oxidative stress and damage to the mitochondrial DNA. Next, decrease toxin exposure. This is true for virtually every disease, but because of the huge metabolic activity of the mitochondria, they are especially susceptible. Next, provide nutrients that protect the mitochondria from oxidative stress. And then we can utilize nutrients that facilitate mitochondrial ATP production. Finally, build muscle mass. Even those with mitochondrial damage, such as that found in Parkinson's disease, can increase ATP production through strength training. The interrelation between the microcirculation and mitochondria is very straightforward. If the microcirculation is damaged or restricted, nutrient and oxygen delivery will be restricted to all cells. Restrictions of nutrients and oxygen to the cells, and therefore to the mitochondria, leads to damage to the mitochondria and reduced energy production. That means less energy than needed to run the metabolism and maintain health. The metabolism is the sum total of all the chemical reactions that run our bodies. Everything that happens with our physical bodies is a result of the billions of chemical reactions that take place every minute of every day. The energy that drives all of those chemical reactions comes from the mitochondria, if and when they're working properly. Once again, if the microcirculation is restricted, the nutrient and oxygen delivery will also be restricted. That reduces the mitochondria's ability to produce ATP, which compromises one's metabolic efficiency. Muscle is the body's largest and most active organ system. It's also our primary metabolic reserve. It's the only place where protein is stored that can be easily accessed. Muscle is also where most of our mitochondria are located, and the main means to increase their activity, volume, and numbers. If the microcirculation is restricted, the mitochondria cannot function properly and will not make sufficient ATP needed to fuel the metabolism properly. That compromises one's metabolic efficiency and overall health. Hopefully it's self-evident that all four of the M's are interdependent. The microcirculation feeds our cells and mitochondria. The mitochondria package energy into ATP to run our metabolism. The metabolism is what allows for life and our very existence. The muscles are our primary metabolic reserve of protein and mitochondria. They also contain most of our microcirculation. If the microcirculation is restricted, the mitochondria become damaged and metabolic efficiency becomes compromised. That compromises one's overall health, leading to disease. I end with the illustration of the 4Ms as a simplified tool to help you understand the underlying cause and mechanism of all chronic disease processes. It's also the key to helping your body to heal and recover from all chronic disease processes, as well as to recover from most, if not all, acute injuries. If you find this information useful and empowering, go to ARTC.health to learn how we support the 4Ms and health, healing at the Age Reversal Technology Center. Thank you for your attention.